Hello and welcome. Let's continue our discussion on problems on types of functions. So here we have to check which one of the following function is one. So we have actually sin x and cos x. So let us plot both cos and sine in the range minus 2 pi to plus 2 pi. The sine wave will be like this, will be like this, and it continues. This is my 0. This is pi by 2. This is pi. This is 3 pi by 2. And this is 2 pi. So this is sine x. This is sine x. And this is my minus pi by 2. This is minus pi. This is minus 3 pi by 2. And this is minus 2 pi. So sine x from minus pi to pi. If you take from minus pi to pi, from here, I'll take this. From here to here. So if I take any horizontal line in this range, in this area, in this interval. So if I take a horizontal line like this, you can easily see. So it touches at 2 points. So this is not 1 1. This is not 1 1 at this interval. So this is not true. From minus 3 pi by 2 to minus pi by 4. This is my minus 3 pi by 2. So minus pi by 4 is somewhere here. So you can clearly see, if you draw a line here, it touches the horizontal line, touches the function at 2 points. So this is also not correct. And so sin x is over. Let us plot cos now. Let us plot cos. Plot cos. Cos is again it is like, right, cos like this. So this is my, at this point, this is my 0 for cos. This is pi by 2. This is 3 pi by 2. This is 2 pi. And this is 0. This is pi by 2. And this is this is my 3 pi by 2. This is pi. This is 2 pi. And similarly here it is minus pi by 2, minus pi, minus pi. This is minus 3 pi by 2, and this is my minus 2 pi. So from minus pi by 2 to pi by 2, so this is the area. This is the interval minus pi. You can clearly see, if I pass a horizontal line like this, touches at 2 points. So this is not correct. So I think this should be the right answer. Let us verify that also. From minus pi to, from pi to 2 pi. From pi to 2 pi, you can clearly see here. This is my pi. This is 2 pi. So if you pass the horizontal line, you can see this horizontal line will not touch the function at 2 points. So this is 1 1. The cos x is 1 1 from, in the range, sorry, in the domain pi to 2 pi, in the interval pi to 2 pi. So okay, this is an interesting problem. We have f of x is equal to root 3 sine 2x minus cos 2x plus 4. So whenever we have problems like this, we have to bring it to either to sine or cos. We have both sine and cos here. How to bring this to only one function? So the coefficient of sine, let us take this as a, and the coefficient of cos, let us take it as b. So the coefficient of a is root 3, coefficient of sin x is root 3, coefficient of b is 1. So what we have to do is, we have to divide and multiply by a square root of a square plus b square, square root of a square plus b square, which is square root of root 3 square plus 1 square, which is square root of 3 plus 1, which is root 4 2. So this factor I'll multiply and divide. 2 into 2 into what I do is root 3 by 2 sine 2x minus 1 by 2 cos 2x plus 2. So if I multiply 2 back to this equation, I'll get back the same equation. So now what I do is, we know that root 3 by 2 is cos pi by 6. Cos pi by 6 is root 3 by 2. Sine 2x I'll keep as it is, minus 1 by 2 is sine pi by 6. You can put sine pi by 3 also here, but to make it sine or cos, we can take anything you want. So we have cos 2x here plus 2 as it is. Now we can see here. Now we can see this is sine a cos b minus cos a sin b. So which is sine of a minus b, sine of a minus b plus 2. So this is actually 2 times sine of a is 2x minus pi by 6 plus 2. So now we need to find, so now this function is actually in the standard form. F of x is equal to, now this function is having only one trigonometric ratio, that is sine. Earlier it was having both sine and cos. Now it is only sine. So now it is easy to find whatever you want. So what is asked? Ask is, this is 1 1 in the interval, so we need to find the interval where it is 1 1. So one thing you need to note here is this the constant term which is outside sine has no role to play in determining the interval of the sine or cos function. So this is a DC value. This contributes to only the amplitude, or this contributes only for the range, not for the domain. So the thing which is inside the sine function, this contributes to the domain or the interval. So we must be worried about only this value. So if I have sine theta, it means theta is between minus pi by 2 to pi by 2. That is, when we have sine theta, f of theta is sine theta, then sine theta is 1 1. Sine theta is 1 1 in the interval minus pi by 2 to plus pi by 2. So here theta value is 2x minus pi by 6. So we should be worried only about the thing which is inside sine function, which is 2x minus pi by 6. So this is minus pi by 2. So what I do is, I have to free this, and we should bring it to only x. We should bring only x from this. So what I do is, I'll add plus pi by 6 on both sides. I'll get pi by minus pi by 2 plus pi by 6 less than or equal to 2x less than or equal to pi by 2 plus pi by 6. So here is minus 90 minus pi by 2 is minus 90 plus 30. So it is minus 60. So minus 60 is minus pi by 3 2x less than or equal to, here we have 90 plus 30, which is 120, or 120, or I can write this as 3 pi by 6 plus pi by 6, 3 pi by 6 plus pi by 6, which is 4 pi by 6 or 2 pi by 3. So this is my 2 pi by 3. Now I'll take this 2 on either side. I'll divide by 2. So when you divide by 2, you'll get minus pi by 6 less than or equal to x less than or equal to 2 pi by 6, 2 and 3. So now I get minus pi by 6 less than or equal to x less than or equal to pi by 3. So sine 2x minus pi by 6 is 1 1 in this interval, minus pi by 6 to pi by 3. So the option is C. Thanks for watching.